Okay, physics. Let me talk you through these horizontal cliff problems. So we're going to have a projectile that's going directly off. And there are a couple of important things to pull out of this, so and some hints that they give you all the time. So let me walk you through how to do this and what's important about it. So here's my cliff. I'm going to throw something off it. What should I throw off it? You don't need to ask. So there's my armadillo. How many stripes? If you don't know by now, look it up. So I'm going to throw my armadillo. It's going to go off the cliff. And he's going to take some projectile path that's going to go like this, right? So if I was going to make a motion map, so these dots would get further apart, right? So the distance he travels every second is going to go a little bit further as he gets accelerated. But importantly, right, that we're going to worry about two dimensions. And this is going to be always true when we're dealing with projectiles. We're going to worry about two dimensions. So I'm going to worry about my vertical dimension, which is going to have acceleration due to gravity, and I'll worry about my horizontal dimension, which curiously is not affected by gravity. And it's kind of a curious thing in physics that many things that are perpendicular are kind of special cases. So gravity doesn't affect things when we're going this way. And we'll get into, if you get into magnetism, sometimes it's the reverse, where magnetic fields are affected by things moving perpendicularly, but not things moving in the same direction. So curious dimensions matters a lot in physics. So here's what I'm going to do. So the strategy I'm going to do is I'm going to separate things into my vertical and my horizontal components. And I'm going to list out everything that I know. So importantly, there are going to be a few clues. So let's talk about the vertical dimension. So let me set some things. I'm going to set this as 0 for my horizontal, and I'm going to set this as 0 for my vertical. That means at the top here, this is going to be some height that I have, and I have some distance that is going to travel all the way out here, d. All right, so this is positive, that's positive as well, right? So which means I'm going to label everything in that direction has to be positive, and everything in that direction has to be positive. So we're going to be careful of it because it's going to matter. So when you think about my vertical direction, so my starting position is going to be the height that he has, and my ending position in that dimension is going to be 0. Let's see, so my vertical velocity that he starts with is going to be 0. So I'm going to think about this, right? So this is going perfectly horizontally, so he starts out with no vertical velocity. Of course, he's going to gain velocities. In the vertical direction, the acceleration, right, that's going to be affected by gravity, so my acceleration, well, v final, I don't know. And my acceleration is going to be negative g. So I'm going to be careful about this. So g is a value, is a magnitude of 9.8. You get to decide the direction. So historically, we assign g as the value of 9.8, and then the negative sign gives it the direction. It's going down towards the center of the Earth. What am I missing here? So time, I don't know how much time is. We'll call it t. So in my horizontal direction, right, now I'm starting with some initial velocity, and this is going to be important. So notice where I'm starting horizontally, though. My horizontal position is going to be 0, and where I end, that's going to end at some distance away from the cliff. I'm going to have initial velocity, which I'll call it v naught, and I'm going to have some final velocity. Be careful about this. This is my horizontal final velocity. What's my horizontal final velocity? It remains unchanged, right? So remember, this direction, acceleration is equal to 0, so the final velocity that it ends with is the same as the velocity it started with. Really helpful. How long does it take to get there? Well, t takes time t, right? So notice all of these things, well, many of these things are different from these things, but there is a connector there. So the connector between these two is the time. So oftentimes it's a matter of going through, frequently you need to go through and figure out a value for time, and then use that value in the other dimension to get to back to what you're interested in. So let's go through this. I'll give you an initial velocity and distance, and we'll figure out height, right? So let's say the initial velocity that we give to this flying armadillo is going to be, I don't know, 10 meters per second. And the distance that he travels, we'll say, say that's 100 meters. So we hurl him off at 10 meters per second. That's pretty quick. That's like, what, 20, 25 miles an hour? So yeah, he's going pretty good. Twisting and turning, he's going to come, and he's going to land here. A bunch of rocks, right? Yeah, rocks. Jagged teeth, though. Something eating him. There we go. He's going to, giant fish is going to eat him. So, so he's going to land here some distance. That's 100 meters away. So what I'm going to do is I'm going to say, well, what can I do to get, so I know distance is equal to 100. So I'll change this to 100 meters. And I know my initial velocity here in this horizontal direction is 10 meters per second. I'm trying to get to height. So here's what I'm going to do. So I'm going to go through my horizontal dimension. I'm going to find time, and then I'll use time on this side. Okay, I'm going to do this the physics way, though, first. I'm not going to actually get a value for this. So here's what I'm going to do. Oh, where'd it go? There it is. Oh, good grief. So you probably couldn't see that for the last couple minutes. So here's what I'm doing in the horizontal direction. So I'm using this equation, which doesn't have final velocity. I've put y's in there, and I've plugged in various numbers, and now I'm going to simplify it. Convince yourself that that makes sense. I'm hoping that's right. So now I'm going to plug in. So notice G is positive, right? So I put a negative sign there. So G is 9.8. 9.8 times my distance, which is 100. I'm going to square that. I'm going to divide by 2 times the square of velocity, which is 100, 490 meters. Whew, that is a tall cliff, right? Probably not so healthy for the armadillo. Anyway, this is a cliff problem. So a couple important things, and conceptually, it's really important. So you can tackle these in a couple of different ways. Another thing that's helpful for this is to think, well, I could figure out the time it takes for something in my vertical direction if I just dropped it. Since my initial vertical velocity is 0, right? The time it takes for this projectile to go all the way down here is going to be the same time as if I just dropped it and it hit the ground. And I think about that for a minute, right? So the vertical velocity is affected by gravity. My horizontal velocity is not affected by gravity, right? So the only thing that's pulling this down is acceleration due to gravity and the initial vertical velocity. So if I drop something and hurl it straight off a cliff, they'll hit the ground exactly the same time. And if we were in a classroom, I could do a nice demo to show you that, but we're not there. So if you wanted to find time, you can, and if something's going horizontally off a cliff, you can say, well, how much time would it take if I just dropped it for it to get to the ground? And that time is going to tell you how long it's going to take to get there along this curve. Anyway, I hope it's helpful. We'll get into projectiles that are being launched upwards at an angle in just a minute, like footballs, and we'll talk to you soon. Bye.